How's it going, everybody? I'd like to thank all of you that have been a continued subscriber, whether you're new or old. If you've subscribed, or even if you don't subscribe, but you still watch the videos, thank you for your support. That's huge. If it wasn't for you, or all of you, I should say, the channel pretty much really wouldn't matter. So, what we're going to be talking about in this video is VMware's Network Virtualization, or NSX as it's commonly coined. So what we're going to be taking a look at is what exactly is NSX and some of the background to it. And it's kind of more of a free-form type deal. I'm going to explain to you some of the things that need to be in place in order for you to successfully execute NSX and some of the things that you can utilize with it. And I'll also talk about some of the things that NSX does not do. And we'll talk about how that goes into play. As it sits right now, currently, at the time of this recording, it's the beginning of September 2016, for those of you that are keeping track of when I record videos. There is a bill of materials out there for myself to go out, and I have to build out a network segmentation design for the company that I work for. And so it was pretty obvious to me from the virtual side how I was going to go about doing that, and NSX was going to be how I do that. And NSX, if you've not had a whole lot of exposure to it, is kind of like one of those, at least in my opinion, is a whiz-bang wow type of situation where you really have to know what's up in order for you to really understand what's going on with it. And I feel that if you have a strong background in networking, then NSX is even easier. But out of the gate, I had a really hard time wrapping my head around this thing known as network virtualization. It's like, well, how do you virtualize networks? You know, because to me, if I see a network, I understand what a VLAN is, and I know how to take a router and break it up into multiple logical routers, or VRFs, and stuff like that, but I'm doing that either on a virtual machine or I'm doing that on a physical router, something along those lines. I couldn't take what all the marketing and all the free training out there was trying to basically hand over to me, and I couldn't put the two and two together. So it wasn't until VMware came on site and started to break down what NSX really is. And then as soon as they started explaining it, I just let them talk. You know, I didn't sit there with any preconceived notions. I didn't have any expectations. I let them explain it to me, and I absorbed the material as they were explaining it. And the more and more they talked about it, the more and more I understood. Then I had specific questions about how certain things worked. So we're going to talk about what they are and how they work, because then at that point in time, it's going to be one of those things where if you understand the general purpose for network virtualization, it'll make things a lot simpler. So that's one of the reasons why I'm recording this video, is because I have what I consider to be a better than basic understanding of how things work when it comes to network virtualization. So I figure, you know what? Let's go ahead and kick off a little video on how things are put together. So network virtualization, if you don't know what this is, it's actually pretty cool stuff. And it wasn't until, like I said recently, that actually, one second for me, folks. I have to fix a problem that I've got here. Let me go ahead and fix this real quick. Yes. Give me 1 second. There we go. All right, so network virtualization, or NSX as it's commonly coined. What network virtualization is basically the ability of taking a network and virtualizing it in software and allowing it to kind of ride on top of your existing infrastructure. So here we have, let's assume that down here on the bottom here, this line that's connecting all these hosts right here, and all of these guys are ESXi. Not ESX, they're ESXi. ESXi, any version of 5.x and newer will support NSX. So This is ESXi and ESXi. Okay, so we understand all that, right? What we're going to be taking a look at is down here, this interconnectivity. We have our management traffic, we have our SAN traffic, and for right now, that's all we're going to have to work with. So we don't need to deal with anything else. So what I'm going to do is physical infrastructure is down here at the bottom. I'm going to draw all of the NSX specific things up top. Now the management and the SAN are going to be for management, obviously for managing these hosts, and SAN for providing the shared storage that each one of the hosts is going to need in order to facilitate the advanced capabilities. Things like high availability, vMotion, things like that. We'll say clusters. So that's going to be how we go about doing that. Now, what actually is happening up here at the top is, if we come up here, I'm going to draw a double line, because we always have two of everything when we're building out networks, right? Because we always want redundancy. What we're going to have is, I'm going to draw here a switch here, a switch here, and a switch here. I'm drawing out the physical infrastructure first so that you guys can see how the overlay, or NSX, comes into play. So these are going to be Nexus 2Ks. And what I'm actually drawing out here is how the design is for the network that I'm designing at work. So we have Nexus 2Ks, and these 2Ks connect up to a grouping of 5Ks. And these 5Ks are going to be our what? Nexus 5K. Well, the 5K is our top of rack switch, and not necessarily our core or our default gateway, Nexus 5K. Now the 5Ks actually connect up to a single, well actually there's two pair, a pair of 7010 Nexus 7Ks. So we have them VDC'd off, so I'm just going to draw a square here and a square here to where these guys are all going to connect, right? Actually it's an improper connection. So this is how all of my networking is put together in the current environment that I support. So this is how everything is physically wired together. So this is a Nexus 7K, this is a Nexus 7K, right? And everything is connected to it. We have the top of row switch, or we have the top of row, we have the end of rack, right? So the 7K sits inside of the same rack that the physical host sits inside of. Most of the time, they might have fiber cables that go in between the rackings, inter-rack, but in most cases they're local to where the servers are. And then the 5Ks sit near where the 2Ks sit, and the 7Ks sit at the end of the row. This is actually our layer 3 gateway. Everything else flows through here is all layer 2. And we do a bunch of VPC and FEX and things like that. So it's basically how everything is laid out. Now, with this situation here, this is the physical infrastructure up here in red. Now I'm going to switch over to green, and this is going to be our overlay, right? Now, the way that NSX works out here is NSX basically is a network layer that sits on top of your existing infrastructure. So inside of the regular host, you're going to have your virtual distributed switches, which is a requirement in order for this to work. So before we get into how NSX and VXLAN and all other stuff comes into play, let's talk about a moment for how the hosts have to be set up before we get into anything else. The hosts have to be clustered, for one. They have to be clustered. They have to have a virtual distributed switch. Now, what is a VDS? A VDS is a vCenter only configuration. When you have Enterprise Plus licensing enabled, the VDS spans multiple hosts, and the hosts have to be in a cluster because you cannot map any single host outside of a cluster into NSX. Okay, so the hosts have to be clustered. The virtual distributed switches have to be in place. So what ends up happening here, and one thing I'll put out there right now is I'm not going to go into the finite details of how this works. I'm just going to cover the high level stuff so that it makes more sense. So once your hosts are clustered and once a VDS has been rolled out to your host, so you have your management, your IP storage, whether that's Fiber Channel or iSCSI, or FCOE, whatever. It doesn't really make much of a difference how you've put it together. As long as it's in place and you have shared storage between them, you can do all the extra fancy stuff. So the idea here is you roll out the NSX Manager, right? The NSX Manager is rolled out to somewhere in your environment. It doesn't really make much of a difference where. What you do then is you configure the NSX Manager, you map this to vCenter, right? You map it to vCenter, vCenter sees it. You log in, and you initially will log in as the administrator at vSphere.local, and then you'll log in, you'll go ahead and configure it, you'll get a domain set up to you so you can log in as a domain admin and manipulate it. Then you go ahead and you roll out your cluster controller. The cluster controller is going to be the device that connects your ESXi host back to NSX Manager. NSX Manager is reachable via vCenter. So you go into vCenter, you click on the Networking and Security tab that is inside of vCenter at the home page. That takes you to the NSX Manager, and then you go down to where it says Installation, and then Installation, you go ahead and you deploy your cluster controllers. You're going to need 3 of these, and this is for redundancy, right? We never deploy anything in a single point of failure. So you deploy 3 of these. Once you've deployed them, you have a few things you need to do. Whatever the span is for the virtual distributed switch, this is what your transport zone is going to be entailing. The transport zone, the way that I would set it up and the way that I have set it up at work in our pilot program on a couple of hosts that are just there as a way for us to test things out, is whatever the span of the virtual distributed switch is also the span of the transport zone. Now, I'm not going to go into all the finite details of how the transport zone can be manipulated and span inter vSphere distributed switches and things like that. That's a little too much out of the gate. The transport zone determines which host can talk to which host and how. So now once you have all this deployed out, now there are several things that need to be in place before you go ahead and do this. But this is the accelerated pace version, if you will. Now, once the physical environment's in place and you have the virtual aspects of it rolled out, NSX Manager is an OVA that you download from VMware, and then you roll this out. Now, once it's rolled out, this is the only thing you have to roll out in order to get NSX up and running. There is a lot of other capabilities and a lot of other things that are spawned from it. And I said spawned, meaning that the NSX Manager has all of the bits and bytes already baked into it that you need to roll everything out. So your cluster controller is spawned from NSX Manager. Therefore, you don't need to download an additional VM. You don't need to download you don't have to have additional licensing. It comes from the OVA itself. All this stuff is rolled out. You go through your steps to get everything situated. Now, what ends up happening here is you have the host setup, right? So the way that NSX rolls out is in different layers. So you have your layer 2 switching, you have your layer 3 routing, you have your layer 2, 3, and 4 firewall, and then you have your layer, your load balancing, which kind of covers 2 and 3 and parts of 4. So that's basically your capabilities. Now, where NSX comes into play and makes things very, very nice is normally when you have a VM sitting here, and you have a VM sitting here, and you have a VM sitting here, let's say these are all in the green VLAN, right? I'm just going to draw, this guy's green, right? Everybody's in the green VLAN. Now the green VLAN is, in order for these VMs to be able to talk to each other in between the ESXi hosts, that means that the green VLAN has to be present throughout, actually it'll be present throughout the entire network, right? And the green VLAN would have to exist everywhere, on every switch in the physical network that I've drawn a green line next to, right? Now let's say, for instance, we had a blue VLAN, or we had blue VMs. Well, this guy right here sits on here, and so I'm going to go ahead and, we've got blue VMs over here. What they actually do is pretty arbitrary. What port groups they're connected to is arbitrary, but you've named the VLAN green, you've named the VLAN blue, etc. Again, everywhere that VLAN or that VM needs to traverse or talk to another VM in the same sub-broadcast domain, the same VLAN, that VLAN information, that VLAN has to be created, and then the MAC addresses for each one of these VMs has to be learned by the physical network, right? Now, in a rollout like this, it's actually very small. It's very simple. So you've got that the MAC address for this guy is learned in 5 different places. Same thing with this guy. Same thing with this guy. Well, okay, that's fine in this type of a situation. But what happens if you've got a massive environment? What happens if you've got hundreds of hosts? In a situation like the one I'm in, I have, and I'll switch over to light brown here. I have a situation right now where, just in this upper right hand corner real quick, imagine this is my data center. I have rack here, and these are rows of racks, mind you. And I have rows and rows and rows, and I have rows and rows, right? So let's say this is, each one of these right here is 20 racks wide, which means in order for a row to work out, there's 20 racks that are right next to each other across the way here. Same thing here. There's 20 here, and there's 20 here. That means that there's 20, 40, 60, 80, 100, 120 individual racks. Well, in the grand scheme of things, I actually have 40 by 5108 UCS servers. So that means I have 40 physical chassis, and each one of these chassis has 8 half-width blades in it. That means if you multiply 40 by 8, I have 320 servers. That means I can have 320 hosts, right? Well, in a situation like this, I can have multiple 5108s per chassis, or per rack. I'm sorry. So that means if that's the case, I could have, that's not that doesn't take up the capacity of my data center. Now, mind you, this is about a third of the data center that I'm showing you, but that's how it worked out. Well, this is actually pretty close. It's not quite as high, but it's from scale perspective, it fits the bill. Well, if that's the case, that's 320 hosts. If I have a situation like, or if I have let's say for instance I have a green VM over here, and I have a green VM over here, and I have a green VM over here, that means that however the networking is put together throughout this entire setup here, that means that the green VLAN has to be able to communicate here to here. Draw a line over here. All that has to be interconnected by the physical infrastructure in some way. Now, that is true 95% of the time in my environment. There are a couple of exceptions where we're GRE tunneling things over and stuff like that, but that's outside of the scope of this conversation. Now, in a situation like this, that would work. Now, the same thing happens for blue. Actually, that's the wrong color, blue. Same thing for blue. Say I have a blue VM here, I have a blue VM here, I have a blue VM here, and I have a blue VM over here. Right? That means that all these guys have to be interconnected as well. So I have to have this guy connect to this guy, and this guy connect to this guy, and then this guy's got to squeak up through here. So the VLAN sprawl has to be contiguous. That means it has to be every device that all these hosts have to be able to traverse the entire network via in order to reach each other. Okay. Well, my network is very multi-tenant because I have different business units inside of the company that exist. So I have to be able to provide both segmentation and security between these different tenants, because I might have a I work for a very, very large retailer, and this retailer has situations where we have a analytics department where you watch how many customers come and go out of our stores every day, and that's a separate group of servers. But those servers could be, we'll say for the moment the red. So these red servers are sprawled out throughout the network. And literally they are. And I'm not making that up. So you've got these servers that are just popping up wherever. Some of them are in clusters. So vCenter with HA just rolls out a VM based off of DRS and stuff like that. So these things come into play, and here we have a situation where I needed to connect all these servers together, and somehow they get all connected and they talk to each other. Well, then maybe the red VMs need to talk to the blue VMs, because red VMs are the application, but the blue VMs are the database. So now I've got to do inter-VLAN routing on those. All right, so you guys get at least I'm hoping you get the fact that in order for VMs that are spread out throughout the data center, in order for them to talk to each other, the physical infrastructure must support the VLANs that those guys are riding on top of. Okay, everybody gets that part. At least I hope you would. So the same idea where you have a multiple routing domains and stuff like that. You're doing your inter-VLAN routing. The problem that we run into in a scalability design, in the software-defined data center, if you will, or the SDDC as it's commonly coined, the problem you run into with that is that means that anytime that the green VM wants to talk to the blue VM, the traffic has to go out and up to my core, which happens to be my layer 3 gateway, and then has to go back all the way down to talk to this guy, right? So this is outbound, this is inbound, right? Well, okay, that works. The job gets done. Now, mind you, I have port channeled 10 gigabit here, and port channel 10 gigabit here, and port channel 10 gigabit there. So altogether, I have 20 gigabits. I mean, there's more cables ran than that, but that gives you the general idea of how it works. So you have a situation like that comes into play. All right, so now I have, in order for my east to west, well, actually my east to west traffic to be able to talk to each other, they have to travel north and then south again in order for this to work. And remember, the Nexus 2K doesn't have a MAC address table. There's no MAC address table. This is just a dumb switch. The switch's intelligence is hosted either on the 5K or on the 7K. In our case, depending on the particular business unit and depending on which servers it's talking to, that might be server farm, that might be store side, it might be corporate. It depends on which VDC in the 7K it's associated to, and on the 5K it depends on what its role is. I have more FEXs rolled out on the 5Ks than I do on the 7Ks, but they're both there. So in a situation like that, the 2K doesn't hold a MAC address table. The 2K acts like a remote line card of either the 5K or the 7K. Or this, I believe the 6K. I don't have any of those rolled out. I have 2, 5, and 7Ks right now. So a situation like that occurs. All right, great. I have to, the 2K, and they talk VN tag between the 5K and the 2K, or the 2K and the 7K. There's some information in the VN tag. Again, this is just encapsulation, right? It's encapsulating what information the server side is telling it. And now, mind you, when you're dealing with a situation like the 5108s, now I have a mixture of both blade and rack mount. So I have both B series and C series servers deployed. Depends on the situation, which one we go with. More, any applications that can be virtualized that are, any applications that are virtualized go on the B series. Any applications that cannot be virtualized go on the C series. And just because of the fact that it works out, we have much more. We have a higher density of apps that can be virtualized than not being able to be virtualized. So that's how we go about rolling this out. So here we have a situation where if the green VM needs to talk to the blue VM, it has to travel up to the 7K to the default gateway, get routed back down to the same host, the same physical host, to a different port group, and talk to a different VM, different subnet. Because you can have multiple VLAN IDs associated to a port group. So that's how the environment rolls out. Now you might say, okay, that's great. I'm glad to know how your infrastructure is laid out from a high level theory perspective. Where does NSX fit into this mix? All right, well, I'm glad that I set it up the way that I did, because I didn't actually plan on doing it this way, but it made more sense to explain it to you in this way to give you an actual legitimate business use case. So the way that NSX will roll this out. Let me roll this back just a little bit here for you. The way that this rolls out, it's actually pretty cool when you think about it. The way that NSX handles this, and I'm going to remove a lot of the back-end fluff, like the controller VMs and stuff like that. User world agent, I'll talk about those later. The way that NSX rolls this out is different. Now, the way that when NSX rolls this stuff out, it's actually embedding all of these services. So layer 2, layer 3, firewall, and load balancing are embedded in the hypervisor. Now, what is the hypervisor? ESXi. What is ESXi doing? Well, ESXi is taking the network, the CPU, the RAM, and the storage, and is virtualizing it. Basically, it's saying, okay, I have all these hardware resources. I'm going to abstract them and serve them up and allow vSphere or vCenter to serve them up to VMs on a per VM basis. So I can sit there and say, okay, this VM gets 2 gigs of RAM, 2 vCPUs, 40 gigs of hard drive space, and 1 VNIC. Okay, that's how you would break that out. So that's what you would apply to this VM right here. So all those resources I just rattled off would go to this VM, right? All that's great. Now, the benefit to NSX, where nobody else can do this, listen, to my knowledge, no other vendor can do this, because you're basically taking and you're allowing the vendor, so originally ESXi, VMware, is virtualizing the physical infrastructure underneath of the hypervisor. So all of these resources right here are virtualized. Well, they're embedded in the VM kernel. The kernel of the ESXi host is taking care of all of the stuff that goes on underneath. The same thing happens with the network virtualization aspect of it. So take this piece right here where I said the network right here. This is the distributed vSwitch or the standard vSwitch that you're probably accustomed to dealing with. NSX takes that to the next level. What NSX does is it says, okay, well, depending on your needs as an organization and depending on your business forwarding and how you need to operate, will dictate what services and what capabilities inside of NSX you're going to utilize. So what it actually does is it basically takes what they call VXLAN. And VXLAN is used to take connections from these hosts right here. And all of these guys right here fall underneath that category. So what I can do is I can actually, regardless of where they sit over here, so this is our physical layout, how things are placed in the network and stuff like that. This is the physical layout in the network, just so you guys have a way of a reference chart, if you will. But this is how the way that NSX does it. It says, okay, I'm going to build across all of the hosts inside of, say, the store cluster. We'll say the store cluster is what it is. I'm going to build a logical switch that will sit on top of all of these hosts. Regardless of where they physically lay, I'm going to build a logical software switch that sits on top of these hosts. Now, it's not you can't go in there, you can't touch this thing, you can't go up there and shake its cables, or you can't SSH into the switch and look at the port interface configuration. You can't do that. What you can do is, well, actually, I have to be careful what I say, because as far as I know, the logical switch, you can't do that to it. There are other things you can do. So like you can go to the distributed port group and you can do things, but the actual logical switch itself is not manageable as far as I know. What ends up happening here is you can do your layer 2 logical switching. You can do the same thing with routing. You can build what they call distributed logical routers. Now basically what ends up happening here is you deploy a controller VM, and the controller VM gets installed on all the hosts that you want to roll the stuff out on. Now, what ends up happening here is these guys, and this is separate from the cluster controller. The controller VM is a little bit different. The idea here is when you roll this out, you're deploying a device that's going to help manage the underpinnings, if you will, of the logical layer, the logical switching. The logical switching comes into play, and what you do is you place this VM into this vSwitch. This is a port group inside the virtual distributed switch in vCenter. You place this VM inside of this particular logical switch. The same thing with this guy, and the same thing with this guy. Now, once you've done that, what will end up happening is there is a VM kernel adapter that's created when you tell a host that it's going to be joining a NSX environment. Well, the host will get this VM kernel adapter, which is also what they refer to as a VXLAN tunnel endpoint, or a VTEP. VXLAN is how the host-to-host communication is done. So if this VM here, let's say VM1, wants to talk to VM2 in the green VLAN, in order for that to happen, it has to go out of the network onto the physical environment and then get routed through the physical infrastructure and then eventually land on host 2 to talk to VM2. Well, the way the VXLAN does that is the underlying red infrastructure that I drew out here is completely transparent. It's not visible between the VM1 and VM2. As far as VM1 and VM2 are concerned, they are directly connected to the same switch. How is that possible? Because the VTEP, when a VM is added to a logical switch, that VM's information is sent up to the cluster controller. The cluster controller then replicates that information up to the NSX Manager. The NSX Manager sends that information down to the other cluster controllers so that they know about it. And then from there, those cluster controllers go ahead and replicate that information out to the VTEPs that are configured per VLAN. Now, the way that this works out, that's actually supposed to be a P. There's a VTEP here. Now, there's only one VTEP configured. When you configure NSX, you tell the VTEP tunnel how many VLANs it's going to listen for. And then that's how you allow your traffic to go back and forth. Now, I'm not an expert on this stuff. I only know from a really high level. That's why I'm keeping this as high level as I can. But the packet walks are pretty simple, the ones that VMware walked through with me. So the same thing happens with the blue VLAN. I have a VLAN that comes across here, and this is also layer 2, but the blue VLAN. So what ends up happening is this VM gets added to this guy, etc. here, and etc. here. Right? They all get added to that VLAN, that switch, and then this is VM1 and VM2 and then VM3 in those respective port groups for that particular application tier. Whether it's database, web, application, really doesn't make much of a difference. This logical domain. Now, what actually ends up happening here is now I have these two different layer 2 networks. Well, VM1 is the app. Let me do this. Let me draw this in black so it's a little easier to articulate here. VM1 is the app, and VM2 or VM1 VM1 in the green VLAN is the application, and VM1 in the blue VLAN is the database. Well, this guy needs to be able to talk to this guy. Well, normally, VM1 would have to go up to the layer 3 gateway and then back down the infrastructure back to talk to the blue VLAN to talk to the database server. Well, that's not the case anymore. Because what I can do is I can move any of the hypervisor level east to west traffic. I can move those default gateways from the physical infrastructure core down, or whether this is a sub-interface or why is that not writing? A sub-interface, or an SVI, however you want to cut it. I can move it from the physical infrastructure down to the hypervisor level. So I can do layer 3 distributed routing. Now what ends up happening here is I create a distributed logical router, or a DLR, and what I do is I configure, there are what they call these lifts, and what these lifts are is a logical interface. I'm going to have one uplink, and I'm going to have up to 990, why is that not writing? 99 inside or internal. What ends up happening here is I can say, all right, well, I've got two different logical 2 networks, or I'm sorry, logical layer 2 networks. I can create 2 internal interfaces, and I can make this DLR here in black. I can make the DLR the default gateway for this VLAN and the default gateway for that VLAN, and then I can set up here to peer with the controller VM, and then this guy here will peer with this guy via like OSPF, right? I could do something along those lines. That is completely possible. For firewall, I could say, well, I need to have some sort of capability in here to where these guys can't talk to each other. So here, I'm going to go ahead and I'm going to go into the host number 2 and explain this. So here we have a firewall. So we have a DLR on all these different routers. Let me go ahead and just draw this out real quick. So I have the DLR here between these routers, or between these VLANs, and that's how they're connected. Now the orange here is going to be the firewall. The firewall sits in between these guys, and the firewall is layer 2, layer 3, and layer 4. There is no layer 7 inspection, so it doesn't have firepower capabilities. It doesn't have the ability to go in there and advanced malware protection or application visibility and control. It doesn't have any of those advanced capabilities. So what it does is it will look at layer 2, layer 3, and layer 4, and then go ahead and say, all right, well, is there any additional advanced services that I can utilize? One of the cool things is, and one of the things that I'm actually actively looking at here, is the Palo Alto Panorama plugin capability. So we're deploying a lot of Palo Alto where I work because we like its capabilities. Palo Alto has the ability, is the only firewall external service that you can actually do redirects with inside of a security group. Inside of the security composer, I can say, all right, well, I want to say for any traffic that comes in here that's marked, that's set a certain type of traffic, I want to go ahead and tell it to go talk to the Palo Alto and make sure nothing's happening. And then the Palo Alto is signaled, it does its thing, and then it says whether yay or nay, go ahead and send the traffic, or nope, sorry, it doesn't meet compliance, go ahead and drop it. So that's basically how all this comes into play. Load balancing is very similar to that, where you can load balance. You might have 30 or 40 VMs on a particular host, and you can load balance across those however you choose to do so. So this is a high-level aspect of how this works. So that means that over here in the upper right-hand corner, I have several VMs that are rolled out that are sprawled throughout the network. Whether it was intentional or completely just based off of you enabled DRS on a cluster of, say, 20 hosts, and you went ahead and, you know, said, I don't really care, just go ahead and roll them out, and then that's how it happened. So you went ahead and you roll them out, and now you've got VMs that are spread across the entire network. Normally you try to consolidate them to a closer, but sometimes that's not always the capability. Now, I've mentioned VXLAN here. Let's talk about that for a moment. VXLAN, or Virtual Extensible Local Area Network. What does that mean? Well, don't let the term VXLAN scare you. All this is really is just a bigger, newer VLAN. Okay? Now, what's a VLAN? A Virtual Local Area Network. It's how I would normally take a physical switch, or a software switch if you're so inclined, and how I would break it up into multiple layer 2 broadcast domains. Okay, right? VLANs have been around forever. So a VLAN is a way to separate logical layer 2 networks. They go from 1 to 4,095 to give you a total of 4,096 VLANs, right? Now, this is a 12-bit field, right? 12-bit field, that's a fair amount of space, right? Well, in the grand scheme of things, it's actually not that much. So that actually limits your capabilities. Where VXLAN comes into play, VXLAN is a 24-bit field. And it starts off at 5,000 and goes through 16.7 million. Okay. Now, again, don't let the term freak you out. Because really all you're doing is you're replacing VLAN with VXLAN. It's encapsulation at the end of the day. Because a VLAN is only locally significant and has to be replicated to all the devices, like up here. The VLANs have to be replicated to everything that I'm drawing a check mark next to because of the fact of the nature of its job. It's to segment broadcast domains to make them more manageable. Well, a VLAN indicates that I need to have connectivity from host 1 to host 2 through the physical infrastructure. Okay, as long as that is in place and you have reachability on your connections between your hosts, you've got most of what you need done already. VXLAN simply comes in here and replaces the VLAN. When you set this stuff up, you actually tell it using the VXLAN network identifier, or the VNI. Basically what you're doing here is you're telling it what it's going to be able to scale to. So I usually choose 5,001. This is the first number I choose. And then I can scale up from there. What you're basically doing is you're giving it another layer to work with. So VXLAN is just an encapsulation to handle traffic between physical hosts where a logical network, whether it's layer 2, layer 3, firewall, or load balancer that is deployed via NSX communicates through. So if let's say VM1 in the green VLAN wants to talk to VM2 in the green VLAN on host 2, in order for that to work, the traffic has to leave. I'm going to go ahead and use that color works. What ends up happening is this information right here, regardless of the type of traffic that it is, it doesn't matter what leaves the VM. Okay, this could be ARP, right? It could be ARP. If it's ARP, not a big deal. Whatever leaves the NIC, the VNIC of this VM, goes onto the logical layer 2 switch, and then it comes up here to the VTEP. The VTEP is basically your exit point for any of the NSX rolled out services, layer 2, layer 3, etc. What ends up happening here is the ARP, that's actually a horrible color. I'll use black, it's easier to see. Say it ARPs. It says, I need to know how to get a hold of VM2. Okay, it hasn't learned that. It actually will, so it's kind of a bad example, but I'll explain how that works here in just a minute. Don't want to do that. The way that this works out, sorry about that, is this ARP is encapsulated. Say this is the ARP frame. It's ARP. Then as it leaves, it goes out the VTEP. The VTEP encapsulates it inside of VXLAN, and then that gets encapsulated inside of UDP, and then UDP. That gets encapsulated inside of IP. That gets encapsulated inside of Ethernet. Now that's the encapsulation breakdown. Okay, so what do I have to be concerned about? From host 1 to host 2, what matters to me? Well, what you see when the traffic leaves the host and is on the physical infrastructure, you'll see the VXLAN, you'll see that header encapsulation, but you're not actually routing based off of VXLAN. What you're routing off of, if it's the same subnet between host 1 and host 2, you're routing it off the destination MAC address. If host 1 and host 2 are not reachable on the same subnet, then you're routing based off the next hop IP. You go to the default gateway, then you route based off of that. The UDP is just the broadcast capability that's built into it in order for it to be able to talk in between the networks. The VXLAN is hiding all of this information over here. I shouldn't say hiding, it's encapsulating it. It says it's the exact same thing as you configuring a GRE tunnel between two routers and you routing traffic over it. The underlying, the routers might be hundreds of hops away from each other, right? The tunnel makes whatever the next hop is look one hop away. VXLAN does the exact same thing. So all the VM traffic here in the green VM and the green VLAN and the blue VLAN, doesn't matter how many hosts are associated to that. Or I'm sorry, it doesn't matter how many VMs are associated to that green VLAN. What matters is its reachability. As long as host 1 can IP reach host 2 and host 3, then you know that they're going to be able to talk to each other because of the fact of the reachability from the physical infrastructure. The physical infrastructure has to be in place. And I've had some discussions with some people that are pretty savvy in the VMware world, and they said, well, what about if you have a hotspot in your underlay? What if your underlay isn't working correctly? Or you've got issues there? Well, sorry for you, you need to fix your crap. Because if you've got a crap design, you've got a crap network, you got to fix your crap. Because at the end of the day, it doesn't matter what whiz-bang wow feature, like whether it's NSX or GRE tunneling or whatever, it doesn't matter what the overlay is. What matters is you have a solid design that is going to scale. If you've got some sort of network congestion in the network, you need to handle that before you throw VXLAN on it, because all that's doing is it's increasing the header space in the packet. The one major thing that I haven't touched on here is you need to increase your MTU to 1600 or enable jumbo frames. If you enable jumbo frames or jumbo MTU, if you enable that, that allows you to go to 96 and change. I forget what it is off the top of my head. 9612, 9624, something like that. That allows you to go up to that size of MTU. Now, if that's the case, great. More power to you. But this is how the breakdown works. So there's things that I left out for simplicity reasons. There's a lot of stuff that I haven't talked about, but there's other things that are out there that still need to be discussed. But this is a high-level overview. So anything that sits in red, that is physical, all that right there is completely oblivious to what's happening in the NSX world. Think of this from a service provider perspective. If you have MPLS, let's see here, MPLS L2 VPN. It doesn't matter if this is Atom, any transport over MPLS, VPLS, hierarchical VPLS, PBB, EVPN. It doesn't matter, because when let's assume that host 2 and host 3 are physical routers, and they have a layer 2 circuit between the two that they connect to. And this guy here is .2, this guy over here is .3. If .2 wants to ping .3, as long as they're in the same subnet, they'll be able to talk to each other. And they'll be able to run a routing protocol between them. Because the service provider's network is just a bridge for host 2 and host 3, or in this case here, the physical network, the physical underlay, is just a forwarding mechanism for host 2 to talk to host 3. The VXLAN overlay is simply just that. It's an overlay. It's a software tunnel that connects two hosts together. And then whatever the communication between the VMs that are sitting inside of the logical 2 switch are, that information is simply encapsulated inside of VXLAN and shipped out the VTAP. Now, how this information is learned, the moment a VM is placed on the logical layer 2 switch, or in the port group that has been built by that VM's information is automatically replicated to the controller, or to the cluster controller. The cluster controller lets the NSX Manager know. That information is then relayed to the other cluster controllers. Those cluster controllers then advertise that information down to the other hosts and the VTAP information. So you have they call the VTAP table, and that holds the information of the layer 2, layer 3, the other VTAP information, and then the VNI that you're going to be reaching it on. All that information is available in the VTAP, so you know exactly who to reach and how to get there. So it's authoritatively learned. It's not a flood and learn like Ethernet. It's kind of similar to the way that fiber channel works, where you actually have to log in and you have to have a dedicated connection from initiator to target through the fabric. The same kind of concept applies. With vSphere switching, you authoritatively learn the MAC addresses because the vSwitch itself is the one that allocates the MAC address to the VM. Since it allocates the VM the MAC, there's no learning process in play. Where a normal physical Ethernet switch has to listen for ARP information and stuff like that, and to say, okay, I learned this MAC on this port, therefore I'm going to build the MAC address table in that regard, or in a flood learn type of capability. That's not the same thing inside of the vSwitch inside of VMware. It doesn't do that. So by authoritatively learning it, by giving the MAC address to the VM, you're bypassing a lot of those other control mechanisms that are out there that make networking not a little bit more kind of shooting from the hip, if you will. Here, you're being very specific. You're learning information you need to know. One of the cool things that I like about the NSX thing is firewall rules follow the VM. Routing follows the VM. Load balancing follows the VM. So if I have layer 2, or if I have firewall rules at layer 2, 3, or 4 that are specific to a VM, wherever that VM is either vMotioned or whatever, if that VM is moved from host 2 to host 3 or host 1 to host 3 or whatever, if it's moved around the network based off of whatever needs, then those policies for that particular VM follow that VM. So the nice thing about that is, if I have, let's say for instance, I have some sort of a gigantic ACL on my 7K for whatever reason, I don't have to maintain 1,000 entry ACL to support all the VMs that I might be having, because you want to make sure that, you know, a VM1 doesn't talk to VM2 for whatever reason. You know, maybe there's some sort of conflict that's out there. So I can sit there, and those rules, those policies that are built inside of the NSX environment move with that VM. The moment that VM is removed, so are those policies and those rules. So I don't have to say, okay, I blew away this particular VM. You don't have to contact the security team and the network team to go ahead and disable that default gateway or blow away those firewall rules, and then you're kind of guessing as to what's where. So you're increasing you're making the network a bit more dynamic, a little bit more automated. You can also take this information and bridge it into vRealize Operations Manager and the Log Insight and Network Insight, so you can see what's going on where. And now, one of the things that it cannot do is, this is not a replacement for your physical infrastructure. So let's talk about that for a minute. Let's say, for instance, this is everything that I've talked about so far is specific to the virtual environment, talking to other areas of the virtual environment, right? Well, that works out quite well. Well, as your network grows, right, that works. However, the drawback to that, though, is if I'm going to be doing that, I need to make sure that I am handling traffic appropriately. What if I need to leave the virtual infrastructure and go to the physical infrastructure? How do I do that? Well, there's this thing called the NSX Edge Gateway. This is your exit, for lack of a better term, off of the virtual infrastructure and onto the physical infrastructure. You can form, and basically that's what I showed up here, where I can form a routing adjacency with the 7K, whether it's BGP or OSPF, doesn't really make much of a difference. I can form a routing adjacency using the NSX Edge Gateway to the physical infrastructure. And then I can go ahead and learn routing information that way. So then I can get traffic from the VM to the physical infrastructure and back if I need to. So you can do that as well. You can also set up VPNs and SSL layer 2, layer 3 VPNs and stuff like that, so that you can get that information between wherever it needs to go. Now, one of the things that needs to be understood here when you're talking about firewalling, what ends up happening here is, as traffic leaves the VNIC, it hits the firewall. If the firewall policies say permit, then the information that came from the VM is then placed on the wire, which happens to be the logical switch, and then from the logical switch, it is determined where it's going to go. If the destination is a host 2's VTEP information with the MAC address of VM2 over here, then that information is passed to the logical switch, hits the VTEP, and then the VTEP encapsulates it inside a VXLAN, ships it across the network to host 2, and then that information is decapsulated. It's firewall checked first, and then once it's firewall checked, it's delivered to the wire, the logical switch, and then delivered to the VM. So there's a process to this, and if you understand the process behind the packet walk, that's going to be huge. So I'm planning on doing more and more of these as I go along, as I start learning this more and more. There's more of more podcast related type stuff and high level breakdown to how things work, because ultimately that's probably the best way. Like I said, there's things that I left out, like the user world agent, which talks to between the cluster controller and the host. You know, kind of like VPXA and the vCenter talks to the host, and you know, you have the CMI communication channel and things like that. So there's several things that can be brought into play. So yes, you can do inter vCenter, you can do cross VC, you can do all kinds of stuff. Those are more advanced capabilities, and you're welcome to try them out if you have the capability of doing so. I'm actually having a lot of problems getting my NSX environment up and running, and I've got my environment to a point now where I can start rolling it out. I get a couple cluster controllers rolled out, and then I start to get the host introspection and the VM security in place, and then after that it's pretty much, it bugs out. And so there's things that are working, other things that are not. The main thing here is NSX is designed to help scale the network out without having to bother the network team or provision physical hardware or go in there and make massive changes. So the idea here is I no longer have to go to the network team, and I being a guy on the network team, I don't have to go out there and justify buying a $3,500 switch or something. I can just go ahead and roll out a service, make sure I go into, I'll manage the NSX environment. That's not a big deal. I have to go out there and provision the new services, build the new layer logical switches and stuff like that, and get the NSX environment to support the new capability. But once that's in play, that makes scaling your data center extremely huge. I mean, scalability is a number one factor in networks today. And if you can get that piece knocked out, you're in really, really, really good shape. So that's what I wanted to talk to you guys about today, and stuff like that. So I just noticed that I've ran out of white paper, ran out of space. So I'm gonna have to figure out how I'm gonna handle that. But that's really what it boils down to at the end of the day. So go ahead, if you'd like, comment below. But just remember, there are things that I left out, so don't beat me up if I didn't properly discuss something or I left something out. I covered high level to put things into perspective for people, and I didn't get into the meat and potatoes out of the gate for obvious reasons. So until next time, you guys have been awesome. Please continue to subscribe. Hit the like button if you liked the video. Let me know if you want to see more stuff on that, or if there's other topics that you would like me to go do whiteboard sessions with and do chalk talk, if you will. Until next time, you guys be cool, be safe, and respect each other.